Hello everyone, welcome back to EducQuiz. Today we are going to dive into a new topic called graphs. This is from two topics. We're going to do the introduction to graphs. So during this chapter, we're going to learn Cartesian coordinates. We are going to see what are Cartesian coordinates. We're also going to see inside it, we're going to see coordinate systems. We're going to learn quadrants, how to plot points, how to read coordinates. We're going to know how to solve the distance between 2 points, how to calculate the midpoint of a line. I'm going to see in 3.2, we're going to dive into linear graphs. There we see region and slope, the equation of a line. We're going to then also draw a linear graph, how to find values from graph, how to find the equation of a line from points given to you. We're also going to learn how, in 3.3, we're going to learn distance time graphs. Everything concerning it. So under it, we're going to learn understanding distance time graphs, reading distance time graphs, drawing distance time graph, calculating average speed, and calculating many other things. So let's start with 3.1 Cartesian coordinates. There are many types of coordinates. These are Cartesian coordinates as the one to focus on. When you go to higher classes, you see polar coordinates, you see some other type of coordinates. So now I want to learn Cartesian coordinates. So first is coordinate system. Let's see what the graph looks like. I'm sure I've seen this before. So if not, that's okay, you're going to detail it. This is a graph working on y-axis and x-axis. This axis is called the y-axis. It's some thickness color chalk. This is the y-axis, the vertical axis. And the horizontal axis is called the x-axis. So on the axis you have values like 1, 2, 3, 4. It continues to to 1, 2, 3, 4. The middle area is 0. So the starting point is 0. You can have 1, 2, 3, 4 until forever there. 1, 2, 3, 4 until forever out. Leave it sit down. So if you have 4, 3, 2, 1, you say roll with the 1 down. Or that you have negative 1, negative 2, negative 3, negative 4 until you use the negative side. Here you have also negative 1 for 4, 3, 2, 1. After this 0 comes, before this 0 comes the negative x-axis. That's how it's been called. So here I have negative 1, negative 2, negative 3, negative 4. See behind it. So coordinate system. Let's okay. Let's say you want to plot some point. Okay, let's say you have some point, it's point here. This is a point in the graph. The representation is 1 and 1. If you want to call this point, if you want to read this point, how are you going to read it? Reading coordinates, we are going to reach there. Before then, let's go to quadrants. At least we know how a coordinate, a Cartesian plane line, Cartesian graph looks like. Let's go to quadrants. The first quadrant here is 1. Where you have positive x and positive y. So when you want to read a point, I think I should have read point before. When you want to read your point, if you want to read this point here, how will you read it? You read it by saying the x value of the point is 1. The point is situated at x equal 1 and y equal 1. So when you want to rate it, you will say x is equal to 1 and y is equal to 1 like this. It reads like this type of form. That's the coordinates. These are the coordinates of this point. This one they call it the coordinates. These are the coordinates of this point. So to name the point, to give the coordinates of a point, you give first the coordinates of our x-axis and the coordinates of its y-axis. If the point is here, and they ask you what are the coordinates of this point here, you are going to first look at the coordinate of the x-axis of the point. Here, it is 4. Already are 4 here, and the y-axis, where is it? It is 3. Here, 3. So 4, 3 is the coordinate of this second point. Then see what the coordinate of this point here. What is it going to be? You have on the y-axis 4, on the x-axis 3. So how do you call it? You call it 3, 4. 3, 4. Those are the coordinates of this point. So that is how you reach values on a graph. So now I'll be using values that are positive. What is the point is here. If the point is here, how do you reach it? I'm going to say you always read the x first, then the y. So you put your bracket. This point has coordinates. On the x we have 3, right? Because 3 is up, down, you see 3. It is on the position 3. On the y, it is at position what? Well, let's assume this minus 2. Correct decimal points. That will be minus 2 because it is at the negative side of the y. So the x position is 3. So when you reach there, you look at where is the x-axis. This is the x-axis. Where is this point compared to the x-axis? It is. You drive vertically upward, you have the point compared to the x-axis, it is at 3. On the y-axis, where is it? It is at minus 2. So to have the x-axis, a value of the x-axis, you always go on the vertical line. You always draw it. So if you have to point here, to know its x-axis, you always draw a vertical line. You touch the x-axis by some point, meaning here, meaning B. You always be touching the x-axis at some point. At that point, you read the coordinate that is there. You see, you know. So what I mean is that you cannot be looking for the coordinate of a point and maybe do like this. Maybe do like this to have the value and say it is this. No, you always have to go vertically upward or downward, and horizontally, either leftward or rightward. Inside. So that is how you read one of this point here. Or you going to read that point. So what is the x-axis? What is the x coordinate at this point? X is right up there. What is the x coordinate at this point? You double. Right? This is really is minus 3. You ho and it's minus 3. Here, what is the y coordinate of the point? You go sideways. You reach minus 4. That is the coordinate of this point. And when you calculate coordinate, when you find the coordinate, you put beside the point. Except the answer answer. What is the coordinate of the point? Then you write under the coordinate of the on is minus 3 and 4. But this is not ask you and you want to know, you just write it beside. For instance, here it is 3 and minus 2. Here it is x is 4, y is 3. It's easy as well. Here it is x down the scale and y this. So that's how you read coordinates on the Cartesian plane. So now that we know how to read coordinates on a beam, let's check this quadrants. Let's take importance. So here, you know that every value that you got here will be positive and positive. You have plus plus. Since you have plus plus, that will be called the first quad. Put on number one. First, we write the first quadrant. From the different color chart. And get below. This is the first one now. So know the second letter and the fourth, you just go in simple hierarchy. This way, anti-clockwise. So this is Spence, simple, E. Just go anti-clockwise, you know this. If this is first, then this is second, third, and fourth. How do you know the first? The place where it is close and plus. That's how you know it's the first. So from the first, we know this is second, this is third, this is two. Because goes anti-clockwise from circular patch. So this will be a second quadrant. This is the third quadrant. This is the fourth quadrant. So you have to keep these quadrants in mind. Why do you have to keep it in mind? Because sometimes they can ask you in which quadrant is located the point 3 minus 2. You have to be able to plot this point and tell that this point is in quadrant 3 maybe. Let's plot this point and check in which quadrant it is. So x is 3. Our x is 3. You know this is 3. Our y is minus 2. Where is y? This is y. Where is minus 2? This is minus 2 on the y. So it is here. So in which quadrant is that? You can see that it is on the fourth quadrant. Then your answer is exactly sure with that. The point 3 minus 2 is located on the fourth quadrant. So you have to know the quadrants, because you can ask you such questions. So those are the quadrants. So you will see that the first quadrant is always positive. The values on the first quadrant are always positive. Whether you take 1 and 1 is positive, whether you take 2 and 2 is positive, whether you take 3 and 2 positive, both of them will cause plus. So each number that they give you that has plus and plus, you know that it is on the first quadrant. So the value of the sign of the x is plus and the sign of the y times associated plus, you know that it is in the first quadrant. For the second quadrant, your x will always be negative and your y will always be positive. You see, for example, if you have minus 4 and 4, the value of x, you know the first point is always the x. The value of x here is negative. The value of y here is positive. Let's plot y. See that this is on second quadrant. X is minus 2. Where is x? This is x. Where is minus 2? Let's check minus 2 on this line of x. Y is 4, 3, 2, 1, 0. Minus 1, minus 2. This is minus 1 on this line. What is y? Y is 4. Where is the y line? This is y. Let's check for 4 on this line. So it's got 4. This is always die 4. So minus 2 and 4, we just brought it until and reach 4. Okay. This is the point. Where you reach quadrant is that point. Consider the points of the second quadrant. So they can ask you a question to in which quadrant is this point, which quadrant is this point. That's why at this level you want to know, you have to know the quadrants. You see greater importance of quadrants when you be calculating angles. For instance, when you be doing polar coordinates, that will be in greater levels. For now, you need quadrants to know in which quadrant a point is. For now, you just have to know the concept of quadrants. Alright, so now we do coordinate systems, labyrinths, quadrants. Let's learn how to plot points. We also know how to read points, coordinates. Person has to plot points. So let's consider a graph like this. What's the banner of board again? Okay, remember this is the x-axis. This is the y-axis. This is 1, 2, 3, 4. This is 1, 2, 3. Can continue to here. Okay. This going to be -1, -2, -3, -4, -12. Continues down. -1, -2, -2, -4. This one. Let's use that way. Okay, we want to learn how to plot points. So let's imagine there's a question in the exam that says plot the point U of and state its quadrant, in which quadrant it is. So let's try to plot the point 3, 4 and state its quadrant. Remember, the first coin when you are plotting a point, when they give you a coordinate of the point, the first point is the coordinate of the x-axis. The second point is the coordinate of the y-axis. So let us look for where is 3 on the x-axis and put a mark there. Where is the x-axis? This is the x-axis. Where is 3? This is 4, this is 3. So you know that your point will be somewhere on the 3, on this line. So where is y? Y is on the 4th position on the y-axis. This point is on the 4th position on the y-axis. Where's the y-axis? This is there. Composition of facing that is not represented natural film. Where? What is going to be somewhere. So we have 3 and 4. 3 was here. 4 is this space here. So I draw this 3. I put my dots until I reach up to 4 there. This is 4 here. I draw this thing until I reach here. And I put my points here, which I will call 3, 4. You see, I have successfully drawn this coordinate on my Cartesian tool in my graph. So this is the point 3, 4. Successfully located it. So that's how you plot points. Let's plot another point. Let's imagine that you ask plot a coin -1, 3. Okay, the question also here asks for the quadrant. In which quadrant this? Without you plotting, you can know that it's on the first quadrant. Why? Because none of these have any negative number. This is 3, 3 is positive, this is 4, 4 is also positive. So you can tell without plotting that it is on the first quadrant. And if you don't know, you can still plot and see that it is on the first quadrant. You see here, this quadrant is the first quadrant. So all of this box here is the first quadrant. So if it was here, it would have been second. It was here, it would have been third, here, fourth. So let's plot now this point. Let's imagine the second question in the exam was to plot this point -1 and 3 and state its quadrant. So let's plot -1 and 3. Remember, this is x and this is y. So where is -1 on the x-axis? Let's look at the x-axis. We have 4, 3, 2, 1, 0 here. This is the 0 point. And here we have -1. So this is the point -1 on the x-axis. You keep this point careful. And the y-axis says 3. So where is the y-axis? This is the y-axis here. Where is 3 on our y-axis? This is the point. So there we go. So 1, 3. Plot this point -1 on the ratio 3. And we put your third care, which we call -1, 3. You see, I've plotted the points -1. X is -1. You look at the x, we see -1, 0 there. Y is 3. Look at Y, you see 3, make it. Then you join it from the X to the Y. You put one point, you know that is a point minus 1, 3. And which quadrant is it? Which quadrant is it? You know it's that this requirement the point is on this second position on this part, the graph. It is a second partner. You can also know without even plotting because the X coordinate is negative and the Y coordinate is positive. So when you have the X coordinate negative and the Y coordinate positive, you know it is on the second quadrant. Or if you don't know, just by looking at the coordinate, you can still plot the points and see that it falls beside the second quadrant. So let's do some 2 other points. Let's do let's plot the points 3 and minus 5 and estimate its quadrant. So where is the point 3 and minus 5 from? Let's plot it. Remember 3 is X and Y is minus 5. So the first step to plot it, you put your X and Y so that you know that the first point is X, the second point is Y. From there, you can already know the quadrant in which it falls. If you don't know, we can plot it and see it or eyes that it falls in this particular quadrant. So let's plot. X is 3. So let's check X. Where is number 3? The 3 and X is here. Really remember 3. So I know that it is somewhere here. And the Y says minus 5. Where is my Y axis? This is the Y axis. This 9. This vertical line is the Y axis. Where is minus 5 on that Y axis? This vertical line. Minus 5 is here. So how to put the point 3 and minus 5. So what do? I draw from 3 down until I reach minus 5 here. I also draw dotted lines minus 5 until I reach some point just equals here. Like that. When I put the lines, know that this is vertically down and this is horizontally rightward. So points 3 minus 5. So this is a point 3 minus 5. And in which quadrant does it fall? This is the fourth quadrant. How do I know it's the fourth quadrant? I always know that the first quadrant is here. This is the first quadrant. So if this is the first quadrant, you just draw the circle going this way. Is first. What is the circle touching next? Second. What is the circle touching next? Third. And this is fourth. But this is just first, second, third, fourth. See, it draws a circle in an anti-clockwise direction. Use. When I say anti-clockwise, I mean the reverse direction of a clock. If you have a clock, you see that the clock this minute thing goes this way, or maybe the seconds E. You'll be moving this way and turning this way, so that it's clockwise direction. Now, anti-clockwise means reverse clockwise direction. We see means the case where this speed moves on the reverse direction instead. So this is it. You follow the anti-clockwise direction, the line just said would be on the reverse direction of the movement of this pin in the clock. So we're going to have the first quadrant as this because it is plus plus until your face. Second will be this, third will be this, fourth will be this. So in which quadrant is this? It's 3 and minus 5 possibly fourth quadrant. So let's plot the last point. Minus 2. Let's plot the points minus 3, minus 4. Where do you think that point is going to be in this curve, kind of, in this graph? So let's plot the point minus 3 and minus 4. Where is minus 3? Remember, this is x and this is y. So look at the x, this is the x. Where is minus 3? All on this line. This is minus 3 here. So put my dot here, another piece is minus 3. Y, what is the y coordinate? Y is minus 4. So where is y here? This is the y line. This vertical line is the y. On this vertical line, there's a note for minus 4. This is it here. So we have our minus 3 and minus 4. How do you plot it? Put the dotted line until you reach minus 4. When you reach minus 4, you stop. Put the dotted line here. Why do I put dotted lines? Because I want to have the precise position of minus 3 and minus 4. So this line is straight. I put dotted line so that I don't miss the line. I don't miss the exact position. You see, I was putting it here. If I just guess that it should be here. I might have the wrong position. If you have a ruler, just put your ruler and point it like. You put your ruler like this until you reach here and put your top. Put your ruler here, no way you reach. You put your block here. When you put your dot, you just put your coordinate next to it. Minus 3. Minus 4, like this. In which quadrant does it fall? This is the first, second, third corner. So just like that, you already know coordinate systems. You already know quadrants. First, second, third, fourth. You already know how to plot points. We plotted 4 points. You already know how to read points before doing all of them. We first write the points. Now let's do the distance between 2 points. To calculate the distance between 2 points, we use a formula. We not just look at it and know the distance between 2 points. And the formula is any value divided by distance to this above the square root of y2 minus y1 minus plus x2 minus x1 squared. This is the formula to calculate the distance between 2 points. So let's take an example and see how it is done. Let's take an example. Let's calculate the distance between the points we have a point given as 1, 2. And the points B given as 4, 6. Alright, let's calculate the distance between A and B. Meaning that A is 1, 2 and B is 4, 6. Now the formula of distance given to us like this. Okay, let's imagine a complete question that in the exam your teacher asks you to and teacher asks you to plot these points to stick the quadrant in which they fall and to calculate the distance between them. So let's first plot the points. We have A is 1, 2. So 1, 2 is x is 1 and y is 2. So where is x1? X is 1 here. Where is y2? Y is 2 here and position here is T. So 1 and 2 meet here at this point here. You put your dotted lines. Where the dotted lines will meet, that's where our constability gives. So here when you put your point, you write there A 1, 2. Then B, x is 4 and y is 6. So you write here 4. The x-axis is 4. 4 is here. The y-axis is 6. 6 is going to be, I keep drawing like this. B. 1, 2, 3, 4, 5, 6. Okay, so we have to plot x be 4, 4 here, and y be 6. Y is 6. Y is going to be 6 at this point. Yeah. So your point B, 4, 6. My one is not that accurate because I don't use a ruler. In your book, if you have a square line book, you can use those squares in your book as one. If you have a square line book like this, you can say this is 1, this is 2, this is 3. Or you can say 2 squares are 1 or 2 squares are 2. Only, well, you know how to drive me a hook because you're waiting out squares. So we plotted the lines A and B. The points A and B. Those are not lines, those are points. These are the coordinates of the points A. These are the coordinates of the point B. We plotted the points A and B. If you join them, we'll form a line. We are going to say lines after. We're going to erase the lines. But now we have points. So, what are the coordinates? What are the quadrants of A and B? A is in the first quadrant. You can see dot coordinate that A is positive, and the x value, the x coordinate of A is positive, and the y coordinate of A is also positive. So the point A is on the first quadrant. Same for B, the x coordinate of B is positive, and the y coordinate of B is also positive. So B lies in the second quadrant. Can also see it with our eyes. At A lies in the first quadrant, is first quadrant. And B lies also on the first quadrant. Since I first quadrant. There's no limit there. There's no limit to the quadrant. Because somebody can see that something is here and say, no, it's not in the first quadrant. There's no touch over now. You can go to infinity right up there. You can go to infinity here. So the only place is here. You look for the y and look for the value of x. It will still be in the first quadrant. So all of this quadrant here is first quadrant. All of this one under here is fourth. All of this one here is second. All of this one here is third quadrant. Alright, so we are to calculate the distance. You already plotted the points. You already stated in which quadrants they are. We are to calculate the distance between the 2 points. So the distance between A and B, right? The distance is going to be square root of, we have y2 minus y1. In this case, what is y2, what is y1? A will have values x1 and y1. So when you have 2 points here and here, that of A is always going to be x1, y1. That of B that they give you is going to be x2, y2. So this is your x1, this is your y1. This is your x2, this is your y2. We'll say this is x1, x2. It's not x1, x2 because you know each coordinate has an x value and a y value. So you put your x and a y, you plot it, then say this is x1, y1. Then the second one will be x2, y2. So when you say this is x2, y2, and this is x1, y1, depends on you. The answer is still going to give the same thing, like representing a distance. So even if you say this is x2, y2, and this one is x1, y1, it is the same thing. Just that here has to be the same number of x and y. This cannot be x1 and y2, and this cannot be x2 and y1. You have to be the same. So this is, if this is x1, this must be y1. If this is x2, this must be y2. I cannot have x1 have the same x1 here. It must be different. So you have x1, y1 to be this point, x2, y2 to be this point. The distance is, the formula for distance is square root of y2 minus y1. What is our y2? We first put our bracket like this. What is our y2? 6 minus, what is our y1? 2. We close our bracket, we put our square, put our close, open our bracket. What is our x2? 4. Our minus, we keep it. What is our x1? 1. We close our bracket and we put back our squares. So that is what we did. What we did. In our previous topics, when we're talking about algebra, we taught how to expand the bracket. Simplify. Okay, there was no square here. You know how to do the square of the number. What is 6 minus 2? 6 minus 2 is 4. We'll have 4 square. Plus, what is 4 minus 1? 3. Have 3 square. You should bless D is equal to, we're going to report to, 1 is 4 squared. 4 times 4, 16. Plus, what is 3 squared? 3 times 3, 9. This is going to be equal to square root of, what is 16 plus 9? 25. And what is square root of 25? 5. And just like that, we have calculated the distance between those points. We calculated the distance between the 2 points. So these 2 points. Distance is 5 units. You have to know that the distance can never be a negative value. Distance can never be negative. So if you have distance as a negative value, we'll start checking back here. The distance here. The distance will be unique. Okay, let's do a second example. Let's do a second example. Let's do the second example. Find the distance between P. The second example goes by find the distance between P being 2 and 3. The coordinates of the point P is 2 and 3. And the coordinates of the point Q is 2 and 8. Okay, that's 2 and 8. Yeah. So how do I find the distance between them? Here I can see that the x coordinates are the same. So I can choose this in my x1, y1, and this in my x2, y2. Here I see that my x coordinates are the same. X is 2 and y is 2. But I want to plot. Okay, let's pause and see how it's going to be on the graph. Let's plot and see how it's going to be on the graph. So let's plot point P. X is 2. Where is x b2? This is x here. Where is x b2? This is x2. And y is 3. Where is y? This is y. Where is 3 on the y-axis? This is 3. So I put my dotted lines on acceleration when y is 3. my dotted lines to one more precision. Here I put my dot. And I put my dot, I put my points P, B, 2, and 3. I'm done plotting my point P. I do same for Q. Where is X? What is the X value of Q? The X value of Q is 2. And what is the Y value of Q? The Y value of Q is 8. Oh, it is not 8 depth. Let's say it is 7. This is 8. This is our Y goes next. You see the X value is 2, so I'll flip it here. The Y value is 8. 8 is right up there. So I'll dot it until I reach 8 because of it. Oh, when I reach 8, I put my dot and I call it P. Finally, Q. Q being 2 and 8. 8 1 data pay. So what do I notice? I notice that these two, one and the other one that was here and here, these two are exactly, it's exactly the vertical line. If I am to plot a line between them, I'll see that the distance between them is just a vertical line. So the distance between them is much now, we'll just say it is 8 minus 3. What is 8 minus 3? It must just be pi. Why will a smart student see that the distance is just 8 minus 3 to pi? Because on the x-axis, the huge difference between Q and K. Both of them fall on the 2. So there's no difference on the x-axis or the about this. Oh, the distance is just on the y-axis because it is just on the y-axis that is a difference. You see the y-axis for the point Q is 8. On the y-axis for the point P is 3. So it is only on the y-axis that you see a difference. So what is in distance? The distance is 8 minus 3, the bigger one and the smaller one. Or if you choose to say that your distance is 3 minus 8, then you take the magnitude. And you still have the same answer, 5, because distance cannot be negated. So let's calculate normally with our formula. We know that distance t is equal to square root of y2 minus y1 squared plus x2 minus x squared. Maybe in your school you'll see distance is equal to square root of x2 minus x1 squared. First, yes, like this case is on this position. Then plus this one is on this other position, y2 minus y1. It's exactly say it's represented. It's exactly the same thing because addition is commutative. Can say 2 plus 3 is equal to 3 plus 3. The same thing whether it's each position, it's still going to give you 5. You see? That's the same thing here. It is plus here. So it's still going to give you the same answer at any time. So let's a quick answer. Let's check it out. So let's check if the answer is actually 5. Comes here as 5, which is 8 minus 3. Right. Let's check this formula and see the answer is 5. First come back our bracket. What is our y2? Our y2 is 8 minus our y1. Y1 is 3. I put my square. Plus, what is our x2? Our x2 is 2. Minus, what is our x1? Our x1 is 10 to put my square and I close my bracket. I'm done. Now I simplify, which implies z is equal to here I'm going to have, when I simplify this, what is 8 minus 3? 5 squared. 5 squared. Plus, what is this? 2 minus 2 is 0. 0 squared is 0. 2 plus 0. So, when I want this 5 squared is 25. which implies d is equal to square root of 25. Square root of 25 is why?
Yeah. So we had the distance below point. We see that it is actually 8 minus 3. 5. It's only 5 using the formula. You see, it's actually this 8 here minus this 3 here. You see the distance here. If that party, you have 0, 1, 2, 3, 4, 5. That's the distance between the 2 points. Let's see.
This is logically 5. Let's take one last example. Or is switched to
A midpoint of line. I know.
So the example goes by
I was working on the button how to meet that here. On the Eva.
sit up he go on this. How about making me about may help on that we are something that base also. What to the cops? Special based by next example, see
I look at the minus 1 4 n is a point minus 1 4